Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is Muneeb here with a new channel, Cambridge Muneeb. Previously, I was always recording my Cambridge videos on chemistry A levels on my YouTube channel Chemistry Master, which is unfortunately now lost by an unfortunate incident of theft with me. And as you know, I was at the line of 7300 plus subscribers when my channel was down. Anyways, now I'm back with my new channel name, which is you can see on the screen as Cambridge Muneeb, and I will be recording my videos again with the new topics on A levels chemistry along with the solving of the past papers. So in this video I'm going to solve the questions of the May-June 2024 variant 1 paper 1. The grade threshold of this paper came out to be 29 for A grade. Before going into the depth with practicing the question, I want to show you my Facebook page on the my Facebook page. Here's my Facebook page. You can see that I still have most of the videos which I uploaded in my YouTube channel. Currently the page has 3.7 followers, and you can basically get out some of the videos of my A levels from this video section. Down here you will find the titles of some of the videos. So if you need any other videos, you can ask me out in the comment section as well as on my community tab, or you can contact me on my WhatsApp number, which you can see on the top of this video. Here is a complete list of all the videos which I made on different past papers practice, some of the lectures on some specific topics of AS and A2, and I hope I will be keep uploading more videos again on the A levels, and I will also upload these videos on the Facebook on this new YouTube channel. Now coming back to the actual video on which I am making video, we are going to start practicing the questions. I have highlighted some of the questions which you can see here. There's a list of these questions. For example, question number 2 and question number 5 and so on. These questions are basically the repeated questions, and I have mentioned from which year and the exam series they were taken. For example, this question number 2 was taken from, can you imagine, this question was taken from 2002 October-November series paper 1. So this question was again repeated in May-June 23 variant 1 paper 1, and question number is 2. And likewise I have mentioned all those repeated questions which are present in this paper 1 of May-June 24. You can find the complete list on in the description section. I have mentioned some additional information. Basically the whole list is here, as well as I have also attached the links of those teachers or students for which they basically solve these questions in their own YouTube channels, in their own videos. So for example, question number 2, you can find the answer of question number 2 on this link, and for question number 5 you can find the answer of that question from this time. Like there are some videos on which the whole past paper was basically recorded, whereas some videos were comprised of only one specific questions. So for those in which the whole paper was solved, I have mentioned the time span in which you can find the answer. You can find these whole details in the description section, so you can simply tap or click on that link and go to the same time period or time span which I have mentioned against that links. So this will help you to understand fully, and it doesn't need to answer again in detail detail in my channel. That's why I'm basically giving credit to all those YouTubers who have solved these questions already in their own YouTube channels. So now come back to the paper. Now for those questions which are not yet answered, I have answered them in this video. Now let's start with the question number 1. The question number 1 states sample X is added to water and made up to a total volume of 200 centimeter cube. This gives a solution of 0.1 mole per dm cube HCl. What is X? Now for this question you need to check the relation. If you remember that you must have studied in your course that there is a formula of N is equivalent to CV. This formula was introduced in O levels. This formula can be modified into a new form, which is C1 V1 is equivalent to C2 and V2. Basically this is the modified form. This formula is used when we have to consider only one compound, just for one compound. For one compound we can use this formula. When one compound has to be changed with its has its dilution changed or its concentration changed, and we use this formula. Now we have this whole list of A to D options. We have to check which formula will follow, which combination will follow or prove this formula. C1 V1 is equal to C2 V2. Now what is C1 and what is V1 V2 C2 over here? I'm going to start with here. Basically it says the sample is added to water and made up to a total volume this, which means that the final form was C2 V2, or you can say the final concentration was the 0.1. The final concentration was 0. This is C2 and the V2 is over here. V2 is 200 centimeter cube. So I have chosen the C2 and V2. Now where are C1 and where are V1? These whole concentrations are C1s and these whole volumes are V1s. So we have to make them equal. Like over here C2 V2 means it is 0.1 times 20 times 200 by mistake, and it gives you 20 mole, because CV means number of mole. But we have to find which of these combinations will give you 20 here. So let's start it. I'm going to do the calculations here. I will write C1 V1 over here. This is the heading, and the calculations for C1 V1 means for this purpose I can write 10 times 0.1. this will give me 10. For the B option it will give me 27. You can check on calculator. C option will give me 20 and D option gives me 30. Now C2 V2 has 20 here, and then over here C option has also 20 here, which means the correct option becomes C. Now moving to the next question, D2, which is already solved, so I'm skipping this question. You can find the answer from the link mentioned in the description. Then moving to the question number 3. The question number 3 says Z is a compound of two elements X and Y. Element X shows a very large increase between its 5th and 6th ionization energies. It has a second largest first ionization energy in its group, and element Y has a large increase between 6 to 7 energies. It has this. Now we are given the details that there are two elements X and Y, and for X and Y element we are provided the values of the energies, ionization energies. So from these ionization energies we need to find out the formula of the compound. Now you can see the working here, but you see that the compound, the element which has the ionization energy between 5th and 6th means the electron in the valence shell, the number of electrons in the valence shell must be 5. So there are 5 electrons. So the element which has 5 electrons belongs to group number 5, and the elements of group number 5 can have 2 valences. It can be 3, it can be 5. So there are 2 valences for this element X, and for element 6 there are 6 electrons, because the large gap between the energy is from 6 to 7, which means there are 6 valence electrons, and for such element the valency can be 6 or 2. So there are 2 valencies. Now from the options given here, we can see that the elements from group number 5 can either be nitrogen or phosphorus, and for element belonging to 6 can be oxygen or sulfur. But here we need to find the combinations as well, because there's a compound of only these 2 elements, which means the options A cannot be the right. A can be the option, it can be either A, because it has element of group number 5 and has an element of group number 6, but option cannot be B, because it has element of group number 5 and group number 7. It can be C and it can be D. Now let's check why is it option C. Now I'm going to construct the formula. Since the element X has 2 valences, 5 and 3, so I have written here 5 and 3 valences, and for element Y I have written both the valences 6 and 2. As you know, when we construct the formula, we basically cross multiply the valences. So for element X it can be either 5 or 3, which can come down to Y, and for X 6 and 2 can come down to below 6. Now if we do it, I can have this combination which is like, for example, if I have this combination and this combination, this is the simplest formula, which means N has 1 and O has 2 atoms. And for P4O10, the simple formula is P2O5. This belongs to that time when the valency of X was taken 5, which moved below the Y as Y5, and the valency of Y was taken 2 and it came below the X as X2. So that's how the formula this matched with this formula P2O5. P2O5 is basically the empirical formula of the P4O10, whereas the valency which we took from the given data had the same empirical formula like P2O5. So that's why the correct option becomes C. C is the correct option. As I told you, it has further empirical formula P2O5, which belongs to similar formula over here X2 Y5. I hope everyone understand it, and if you find any query, you can ask me out on you can reach me out on WhatsApp, or also leave comment in the comment section. Now moving to the next question. The next question states, which statement about iodine 131 is correct? A negative ion of this has this neutrons and this electrons. Now for this purpose you have to calculate the number of the protons and the neutrons. Basically you should know that to calculate number of neutrons, the formula is mass number minus the atomic number. This is mass number and this is the atomic number, and this gives us 78 neutrons. Now protons must be equal to number of electrons if it is the neutral form. Over here the 78 neutrons, option C and D give 78 neutrons, whereas the option D and B give us 54 electrons. Why 54 gives us 54 electrons? Because it is a negative ion. Negative ion means it must be I negative. For I negative, there will be one additional electron as compared to the number of protons present in the atomic number. That's why 54 is correct. So the correct option becomes D. That's the right option. Now moving to the next question. Question number 5 is already solved. Again, its detail can be found in the description with its link and the time of the video. Then question number 6. The question number 6 says the structure of the sulfur dioxide is shown. What is the shape of the sulfur dioxide molecule? I have to show you a part of the literature from my notes where all the angles and the shapes are given. Alright, so here's the PDF file of my AS chemistry notes. I have written notes of whole AS as well as notes of the A2. You can see there are 533 pages of this whole PDF file. So I will go straight to the page which we have to study here. Okay, here's the page. In this page you can find that what should be the shape when we have this number of electron pairs. The number of electron pairs are divided into further two classes, the bonding pairs and the lone pairs. So let's move to the question which we have to discuss here. The question over here says what should be the shape of the sulfur dioxide. Apparently the students can be mistaken to give it as a linear because it seems to be linear here, but that's not the case. That's incorrect. It cannot be linear. Why? Because we have to consider the central element here, and for central element we have over here one bonding pair. We have one lone pair. We have one lone pair and we have two bond pairs. Consider this double covalent bond as single bond pair. So if we consider that a molecule can be linear when it has two bonding pairs. You can see from here when there should be two bonding pairs, then it can be a linear. And for pyramidal shape, it should have one lone pair and three bond pairs. You can see here in the pyramidal of this NH3 trigonal pyramidal, it should have three bond pairs and one lone pair. That's what I have written here. And for tetrahedral there should be four bonding pairs. That will give it tetrahedral. But in the given structure of sulfur dioxide we have one lone pair and two bond pairs. So one lone pair and two bond pairs give us the non-linear shape. It is a non-linear shape. You can see that in my notes. Here we have the band structure, or we can say the non-linear structure is written here, band or non-linear. For this we have two bond pairs and two lone pairs, but these value belongs to H2O and H2S because they have two lone pairs and two bond pairs. Whereas for sulfur dioxide we will say one lone pair and two bond pairs because there are two bond pairs on the either side of the sulfur in this case, like in this question. So the correct option becomes B. Now moving to the next question. The next question is about what is the density of a sample of fluorine gas at 32 degrees centigrade and 100,000 Pascal. Assume fluorine behaves as an ideal gas under these conditions. So basically what we have to do here, we have to find the density and here we need to use this formula PV is equal to nRT. From this PV is equal to nRT, we need to find out the formula of D, which is density, and it becomes PMR over RT. If you don't know how to find this formula from the actual gas equation, I can show you how. We will first take PV is equal to nRT, then we will replace N by mass over relative molecular mass, and then we will rearrange it to find M over V. M over V gives density, and you will get on the left hand side as PM over RT. This M over V is the formula for density. That's how we get the density formula. After doing this, we need to substitute the values of pressure, relative molar mass, and for the rest of the variables R and T. So let's move to that portion, to that side. First we see that it is a fluorine gas. So fluorine gas has this value 38, which is its relative molecular mass. The temperature is 32 degrees centigrade. We will convert it into Kelvin because gases always require the absolute temperature. It cannot be attempted by using the values of centigrade, or even if there is any Fahrenheit, although it doesn't come, but we need to convert centigrade or Celsius into Kelvin because gases always follow the absolute temperature. And then about the pressure. If you are considering the pressure and volume relationship, then remember, when we have the pressure units in Pascal, then we always need to use the volume as meter cube. But if we have the units in kilopascal, then we will get the volume in dm cube, and that's what we have here, dm cube. The units are in dm cube, which means we need to convert this Pascal into the kilopascal, and you will simply divide it by 1000, and that's how you get the value of Pascal. Pressure. What about the volume? Volume over here is under the 32 degrees centigrade, and it is very close to the room temperature. Room temperature, which is in this case can be 25, consider 25 degrees centigrade, is very closer to that. If it was at STP, it was clearly stated, and for STP we have 0 degrees centigrade. So the volumes of these two are different. For room temperature it is 24 dm cube, and for 0 degrees centigrade it is considered 22.4 dm cube. Over here the gas is closer to the room temperature, that's why we will select 24 dm cube. So over here volume has been considered 24 dm cube. Now putting the values here, 100 kilopascal into 38 molar mass into divided by 8.31, which is the molar gas constant, R constant value, and the value for the temperature is 305 Kelvin. You get this value 1.499, and it can be rounded to 1.5 gram per dm cube, and that's the right answer. B is considered the right answer. Now moving to the next question. Question number 8. The graph shows the boiling point of the hydrogen compounds of group 16 elements. We have this graph of H2O, H2S, H2SCC, and H2TE. Which statement correctly explains why water does not fit the trend of the other compounds? So we can see here that water has very highest boiling point, and then it comes down to H2S, and then it again move upward, but not that much drastically. So why H2 has such a highest value? The reason can be linked with the boiling point over here. Boiling point, as you know, is linked with the intermolecular forces, And in the options here, what we have, which is linked with intermolecular forces, there are few electrons in the oxygen atom, so there is less shielding of the nuclear charge. It has nothing to do with intermolecular forces, so it's wrong. There are strong hydrogen bonds in water but not in the other compounds. It can be the right one because it is linked with the hydrogen bonds, and yes, there is no hydrogen bond in H2S, H2SE or H2T. Hydrogen bonds is only present for the compounds containing hydrogen bonded with either nitrogen or oxygen or fluorine, so we have the H2O here. Option C says the covalent bonds of water are much stronger than other compounds. Covalent bond is not linked with the intermolecular forces. And lastly, the water molecules are smaller and so have stronger van der Waals forces. Those molecules which are smaller does not have stronger. They have weak van der Waals forces, but even here that is not linked with the boiling point, so the correct option becomes the hydrogen bonding, because water hydrogen bonds are present in the water molecules. The next question, an energy cycle is shown. The energy changes involved are x, y and z. The numerical value of energy change y is either this 890 or plus 890, and the numerical value of energy change z is either minus 964 plus 964. Which of the three values negative? Okay, we have to find out the negative values of all these three arrows, x, y and z. Negative values mean it indicates exothermic condition, to be more specific. Exothermic condition. Now let's check which is shown in the x case. The x means it is showing the combustion, as well as this the right hand side is also showing the combustion reactions. Slight mistake, only the y side indicates the combustion, because when methane reacts with the oxygen it gives carbon dioxide and water. These two products are basically the products of the combustion, so yeah, that's the combustion enthalpy. Whereas the x is basically the reverse of the formation. Reverse of formation means it can be decomposition of the CH4 with oxygen. So combustion is always, as you know, is a negative value. It is always a negative value. The value of it is always a negative value combustion, whereas the reverse of formation means decomposition, means you require energy to break it, and all those reactions which require energy to break means it indicates positive enthalpy, which is an endothermic. So x will become positive. Now about z is considered as the enthalpy of formation, because you are forming carbon dioxide and water from these three elements in their standard forms. So the value of formation can be either positive or it can be negative, depends upon the situation. Now the question asks us which of these three will be negative. So x is considered positive, so it cannot be x, whereas y is always a negative, and z can also be negative as well. So the option should have y and z combined, and that's why the C option is the right one. Now moving to the next question, number 10. For a certain endothermic reaction, the activation energy is numerically equal to twice the enthalpy change of reaction. Which reaction pathway diagram is correct? Now we are given 4 different diagrams, and we have to select in which the enthalpy of the activation is 2 times the enthalpy of reaction, which means we can say the activation energy value should be 2 times greater than the enthalpy value. Now from here, from these 4 diagrams here, we can select which will be the number 1, which should be the endothermic. As we can see that the diagrams the diagram C and D both are belonging to exothermic case, so these two will be excluded. Now we are left with options A and B. They are both belonging to endothermic case, so it can be one of these two, but we have to see which of these two has 2 times value of activation as compared to enthalpy. So we are already given the grids here on the graph, so you can easily calculate the values using the grids. So I have done this for you. So here you can see the value of activation energy in graph A versus value of enthalpy. For enthalpy we have 1 block, whereas for activation energy we have 3 blocks, 1, 2 and 3 blocks, which means the value of activation is 3 times than the value of the enthalpy. In graph B you have to see carefully the value of the activation energy. You can see it must be from reactants to the top of the hill or peak, whatever you say, peak or hill. So from reactants to the top of the peak here, hill, I should write H here, reactant to hill gives you half of the lower box over here. This is half, and it is also almost half, so you can consider it as half for this and half for this. The value of activation energy will become half. This is the value 1. This is the value of activation and half for one side and half for the other side, so this will give you 1 value. Whereas for the enthalpy, as you know, enthalpy is from the reactant to the product side, so I have to show that side as well. It will start from here and go up to this point, so you can again consider it as, carefully looking at the here, you can see it is almost half, because start from here and it ends over here. This is for the enthalpy, delta H. So enthalpy value is almost half, whereas the value for activation energy is 1. So we can clearly say that the value of activation energy is 2 times the value of enthalpy, and that's why option B is the right one. And I hope the students have clearly understood this question. Now moving to the next question, number 11. This question is already attempted. In the description you can check out the video where this question has been done for you. Now let's move to the next question. Question number 12. Question number 12 says oxygen can be prepared by the reaction of potassium manganate, hydrogen peroxide and sulfuric acid. Each H2O2 molecule loses 2 electrons in this reaction. The other products of the reaction are potassium sulfate, manganese sulfate and water. How many moles of oxygen gas are produced by when 0.1 mole chemical reacts with excess of H2O2? Now this question is kind of tricky here. Although the examiner report is not yet published, but I can guarantee that this question will definitely be included in the examiner report, I hope. Now let's move with the problem solving. For this question, you need to construct the chemical equation in which all of the reactants and the products are mentioned. So I'm going to write the reactants as well as products. So here, from here you can see that the oxygen is prepared, which means oxygen is a product and is prepared by the reaction of potassium manganate, which means it is a reactant, and H2O2 is a reactant and sulfuric acid is a reactant. After this line, it says the products also include the potassium sulfate product, manganese sulfate is a product, and water is a product. So we need to construct this whole equation here. So I'm going to write it. The reactants will include KMMnO4 potassium manganate, plus it has H2O2, and then it has sulfuric acid. These are all the reactants. And now in the product side we have the oxygen, plus we have the potassium sulfate, and then we have the manganese sulfate, and after that we have the water. I have deliberately left these extra spaces to balance the chemical equation because you need to put the coefficients in front of the compounds or the species. Now this chemical equation is there, but when we see at this line that H2O2 molecule loses 2 electrons, it states, and it means that we need to find the number of electrons involved, as well as it has also included when 1 mole of KMnO4 is reacted, which means this chemical equation is not yet balanced. To balance this chemical equation, we need to use again our practicing. Always remember that you can only balance the chemical equation when you have good deal of practicing. Let's start here. Number one rule is that always look for the elements other than carbon, hydrogen and oxygen in such chemical equation. Here in this case we have potassium as a different element, manganese a different element, sulfur is a different element. So I will first balance them out. Okay, now I will balance potassium first because I can easily see that there are 2 potassium, so I will write 2 over here. Now it becomes 2 potassium and as well as 2 manganese, which means I have to balance manganese as well, so I will write 2 over here. Now this is also balanced. After this you need to check how many sulfurs are there. Now in this case the sulfur now will become from this side we have 2 sulfurs here and 1 sulfur is present here. There are 3 sulfurs in total, so I will balance these sulfur from on the reactant side, so I will put 3 over here. Now there are 3 sulfurs. In my case both potassium, all the 3 elements potassium, manganese and sulfur are all balanced. Now I have to balance the elements which are provided in this list: carbon, hydrogen or oxygen. Now we have hydrogen and oxygen here, but in the hydrogen and oxygen case, which should be balanced first? We have to balance hydrogen first. Why is it so? Because oxygen is mentioned as a single element which can be used to balance at the last. So that's the rule. Always balance that element which is present alone at the last. So I will first balance the hydrogen. Okay, now here I have to count the number of hydrogen present on the reactant side. On the reactant side I have 2 hydrogens here. I have 2 hydrogens here and I have 6 hydrogens here. So this will give me 8 on the reactant side, and on the product side I have just 2 hydrogens here, which means I can use this to find the number of the hydrogens. I can use these values to balance the hydrogen. So I can put 4 here, but it is still not balanced, and I will tell you why. Because it requires some additional information here. For the time being I am putting 4 over here to balance it, so I will not put any value in front of the H2O2. Now hydrogens are balanced. We have the 8 hydrogens on either side of the chemical equation. Now at the last I have to check the oxygen. If I count the number of oxygen on the left hand side, I have 4 to 8 oxygens here, 2 over here, and 12 over here. So this will give me 22. My mistake, it gave me 22 oxygens on the left hand side. 4, 8, 2. Now on the right hand side, I can check here. These are 4 over here, I have 8 over here, and I have 4 over here. So this gives me about 16 oxygen atoms of this side and 2 from here, but I have to balance it with 22, which means how much I need 6 additional oxygens. So I will write 3 over here. This will give me 6. So 6 plus 16, this give me 22 oxygens. So although I can say it is balanced, but no, it is not balanced. Just the value over here, these are not balanced. I will tell you why. Because I need to, and also the value of oxygen is also not right over here. Now I will tell why these values are not right. Because we have to check this line over here, that they are each H2O2 is losing 2 electrons. So we have to balance this chemical equation in terms of the electrons as well, not just in terms of the elements and atoms, but also in terms of the electrons. So for this purpose, I'm going to write a ratio, and I'm also write the half equations. We know that the H2O2 is losing 2 electrons, and we have to check which element is showing the gaining of electrons. It means which element is showing the reduction. So we can clearly see that potassium belongs to group 1. It will have +1 oxygen state here. It will not be changed because it will remain the same. So potassium is not being reduced. For sulfur, it is +6 here, it is +6 here, it is +6 here. It is still not changing its oxidation state. All the oxygens except for this H2O2 is changing, because it is -1 over here, because it is a peroxide, and it converts into -2. It means it is being reduced, but we have to check the sorry, I'm saying -1. It is about H2O2. We already know that it says it loses 2 electrons, which means it is showing the oxidation, but we need to find which one is showing the reduction. So we have checked potassium, manganese, sulfur. All the hydrogens have same oxygen state of +1 in all the compounds, but we have not checked manganese. Manganese has +7 oxygen state in KMnO4, and it has +2 oxygen state here. You can check the oxidation numbers to find the value. So we can write now here what is the change we can observe for manganese. It is changing from manganese +7 into manganese +2, which means how many electrons it is gaining? It is gaining 5 electrons. I'm writing it for 1 mole. It is gaining 5 electrons. So for balanced chemical equation, we need to balance the number of electrons lost and gained. It is a rule for electrochemistry. It is always a rule to have same number of electrons lost and gained. So 2 electrons of the H2O2 must be balanced with the 5 electrons. For this purpose, we'll multiply this with 5 here, and we will multiply this with 2 here. When we have done this, we need to multiply this 5 with this H2O2. That's why I said before that it is not balanced yet. So I will put 5 over here. when I will put 5 over here, I need to balance this on the right hand side as well. Now if it is 5 hydrogen here, we have how many hydrogen? 6. So this will give me 16 hydrogens here. So to balance 16, I have to put 8 over here. On the product side, I will write 8 here. Now these are now balanced, 8 hydrogens with 8 hydrogens, but oxygen will not be balanced yet. And for the this 2, I have to write 2. This 2 is already written here, KMnO4 and with 2 MnSO4, so I don't need to change these two values. These are already there. But what I need to check is the number of oxygen atoms, because when manganese is balanced, it means potassium is also balanced, sulfur is also balanced, because all these three compounds contain similar number of manganese, potassium and sulfur. The only left element is the oxygen. I need to check what is the change in terms of the oxygen atom. Now I will write first for the left hand side, because all these three are actually balanced on the left hand side in terms of the elements except for oxygen. So I need to check it. I have 10 oxygen here. I will write in a sequence way. I have 8 oxygen for this, 8. I have 5 to 10 oxygen from here, and I have 12 from here. So in total I have how many oxygen atoms? 30. There are now 30 oxygen atoms on the left hand side. And on the right hand side, how many oxygen atom I have here? I have now, I'm going to raise it. I have 8 from here, 8 from here, 4 from here. So this will give me 22. These are now 22. And how much I need more? I need to make it 30, which means there are now 8 oxygens left. To make it, wait a second, my slight mistake. 8 plus 8 plus 4 gives 20, not 22. It is 20, so I have to make it into 30. So for this purpose I need 10 more oxygen atoms. So for that purpose I will multiply 5 with this oxygen molecule. Now I have now completely balanced the chemical equation, and you can check it by yourself. All the elements are now balanced in terms of the number of atoms as well as in terms of the number of electrons lost and gained. Now the second line of this question says how many moles of oxygen are produced when 1 mole of KMnO4 reacts with an excess of H2O2. Now I need to construct another ratio here. Now the ratio will be between the KMnO4 and O2, oxygen, because it has given me the value of mole versus the moles of the oxygen. So according to balanced chemical equation, I need to find how many moles are there in the balanced chemical equation. There are 2 moles of the KMnO4, so I will write 2 here. And how many moles are there in balanced stoichiometry equation? There are 5. And how many I need to find in terms of 1 mole? This will become X. So to find the value of X, you can write X is equivalent to 5 over 2. So you get the answer 2.5, and that's how you get to the right answer. 2.5 is the correct answer, and that's how the option B is the right one. I hope this question is now understood by everyone, because this question was very much lengthier and some sort of trickier as well. Alright, so before moving ahead, I want to show you something about my resources and my platforms. Students, this is the worksheet of Unit 1 Atomic Structure, and it includes the MCQs of the past 10 to 11 years. You can see that the question starts from May June 2012 and it ends up to May June and 23 up to here. and these are almost 88 questions. I have mentioned the references from where the questions were taken. Along with that, you can also check out the different fonts here. These questions belong to the examiner report, and you can find the exam report attached with the same worksheet, and there is a mark scheme. So you can find the questions very beneficial for your exam preparation. This whole worksheet contains only MCQs, and then I have the paper 2 of the same unit number 1, atomic structure. You can get these worksheets from me directly, and you can again see that the paper structure questions have some limited years starting from May-June 2016 up to May-June and October 2023, and you can see it ends here up to May-June and 2023. Now there is a section of the mark scheme after that, and later on I have attached the examiner report of each and every question mentioned in the same worksheet. So these worksheets will be very beneficial, and students have been getting A and A stars in their A levels because of these worksheet. When they practice the questions, they get almost every concept totally commanded, and they get they are very much well prepared for the exam because of the worksheets. So students, you can get these worksheets directly from me, or you can contact this is the name of the shop from where you can get as well. This shop has its branches in these different points. You can get from F10 Muneeb in Islamabad, PWD Islamabad, Baritone Islamabad, Baritone phase 7 in Rawalpindi, Sadar Rawalpindi, DHA phase 2 Lahore, and their contact number is mentioned here. So if you need these worksheets, you can either contact this shop, or you can contact me directly. Moreover, you can get the worksheets of all the chapters from unit 1 up to last chapter of this AS chemistry. I have worked on worksheets of all the chapters of AS as well as A2. So if you are from A2, or you are giving the accelerated A2 or the composite, you can also get the worksheets for A2 chemistry as well. Moreover, students, I have made the WhatsApp group for my students. I am attaching the group link in my description in my about section, and at the top of the first page of the YouTube channel, you find the link of this WhatsApp group. There are almost 106 members, and they are getting different resources from me. Some of them are also registered for the online tuitions. And here's my Google Classroom. You again find the link in the description. I have almost 315 students in this Google Classroom. These students came into my Google Classroom from my previous YouTube channel, which I am telling you again that it is now lost. That channel name was Chemistry Master, and the videos of those channels have been uploaded on my Facebook page, which is again the same name, Chemistry Master, with the same display picture. So I'm starting again with new channel, with new dreams and new determination, and I hope you students will support me in every way you can, inshallah. Okay, now let's come back to the past paper. We are about to start the question number 13 here. The question 13 states an alcohol reacts reversibly with ethanoic acid to produce ester. You have this chemical equation, and we have these values in terms of moles. We have to find the Kc value for the reaction. Now, as you know, this question is also some sort of tricky one. As you know, the Kc formula for the chemical equation can be written as concentration of the products in numerator divided by concentration of the species in the or reactants in the denominator. Now this is a chemical equation of equilibrium, which means we must have the values for the equilibrium stage, but here we can find their values of two stages. One can be set as initial and the other one can be set in the stage of equilibrium. Now for the alcohol we have this 3 mole, and for ethanoic we have 2. These values were mixed together, which means these values belong to the initial stage. So for initial stage I can write 3 mole for the alcohol and 2 moles for the ethanoic acid, and at this moment there was no amount of the products formed, so I can write zeros for these 2 products. When the equilibrium, at equilibrium states, at equilibrium the amount of this compound, which is an ester, was about 1.5 mole, so I will write 1.5 over here. Now 1.5 for this compound. Now if we look at here, there is a 1-to-1 ratio between all of these compounds in stoichiometric way. In stoichiometric form, there is 1 mole for alcohol, 1 for ethanoic, 1 for ester, 1 for H2O. If it is so, then the amount which is produced for water will also be 1.5 mole. Now these are the moles of the products at equilibrium stage, but what about the amount of the reactants? We have to find that out. Initially the value was 3 for alcohol. Initially alcohol was 3 mole, but the amount of the product formed for ester or water is 1.5, which means 1.5 mole of the product must be subtracted. We have to take into account just one product, not both products must not be minus, because there is 1 mole of the reactant and 1 mole of the other products as well. We are not we do not have actually we don't actually have 1 reactant only, we have 2 reactants here, alcohol and ethanoic acid, so both are reacting together, which means we will subtract 1.5 mole from 3 of the alcohol. We are doing this calculation for alcohol, so the amount at equilibrium of alcohol will be 1.5. This is the amount of the equilibrium. 3 minus 15 gives you 1.5, and this is the value of the alcohol at equilibrium, so I will write 1.5 here. Now for the ethanoic acid. For ethanoic acid, initial amount was 2, but again we have to subtract 1.5 from here. So at equilibrium it should be 2 minus 1.5, so it gives you 0.5 mole. So 0.5 mole for the ethanoic acid. So I will write 0.5 here. Now what about the water? Water was basically taken as a reactant initially, because it said that these 3 were reacted together, were mixed together, but as a result of the reaction the water was not in the reactant side, instead it was in the product side. In the product side water was there, so the whole amount of the water which was taken initially has now been shifted towards the product side. So the 1.5 mole which we calculated from the equilibrium must be added into the 1 mole of the water taken initially. So as a result we will say the actual amount of water in equilibrium will become 1.5 plus 1 as 2.5 mole. This is the value of the water at equilibrium. Now as you know, the formula for the Kc is concentration of products over reactants. I can substitute the values here. The products contains CH 3COOR into concentration of the water divided by concentration of the alcohol times concentration of the ethanoic acid. Now putting the values, I get 1.5 mole for ester in the equilibrium times the amount of water is 2.5 mole divided by 1.5 for the alcohol and 0.5 for the ethanoic acid. So these two will be cancelled from each other and you are getting 2.5 divided by 0.5. The answer is 5 here. So the correct option is D. I hope you understand this question very well. If you want to see at a better version of my working, you can see these calculations done. Now the next question, question number 14 has already been highlighted, which means this question is solved and explained in an already made YouTube video of another person, whose link is given in the description. Then the next question, number 15, it is also highlighted, so which means it is already solved before in another person's video. Question number 16, the same thing. And then question number 17. Now the question number 17, aluminium, silicon and phosphorus are elements in period 3 of the periodic table. Each element forms an oxide. Which row is correct? Now here we have 3 different compounds, and for these compounds we are given some of their properties in the tabular form. Aluminum oxide, silicon oxide and P4O10. We need to check each and every property of all these compounds individually. Only then we can approach to the right answer. Okay, so for aluminum oxide we see that it is a basic. No, aluminum oxide is not basic, and I can show you in my notes. This is a page from my AS chemistry notes. I have mentioned all the properties of all the elements of period number 3 in the tabular form. So here you can see that aluminum oxide. What is the property of the aluminum oxide? You can see here it is amphoteric. It is not a basic, so it becomes incorrect here. It is wrong. It is a giant. Is it a giant ionic? So let's see here the structure of the aluminum oxide below aluminum and in front of the oxide. So yes, it is a giant ionic, so it becomes tick. Does it have a high melting point? So let's see, melting point of the oxide of aluminum oxide. Yes, it has a high melting point. It has a high melting point, so yes, melting point is right. Vigorous reaction with water. So I need to check this in detail, but for the time being I will leave that for later on. Before that, I want to select all the points, all the first 3 points of these 3 compounds from this one single page. Let's check about the silicon oxide. Is it amphoteric? For silicon oxide we can check that it is acidic. It is not amphoteric, because this shows the acid-base nature of the compounds, so it is not an amphoteric. I will select this as wrong. About giant ionic, silicon oxide does have a giant covalent structure, not the ionic structure, so it becomes wrong. High melting point, so the value in front of the silicon oxide is 1710. Yes, that's correct. It considered as a high value. Slight reaction, again I will check it later on. Now about P4O10, does it have Does it have a acidic nature? Yes, it has an acidic nature, so it becomes correct. Simple molecular structure. Yes, it has a simple molecular structure, so yes, it becomes simple molecular. Low melting point. Yes, it has a very low melting point. Sorry, my mistake, I was checking in the column of sulfur. I should check in terms of phosphorus. It is simple molecular, good. And in terms of acidic, yes, it is acidic, and the melting point of phosphorus oxide is 42. So yes, it is true. All these three values of this true. Now we have to check about the D option for all these three compounds. Let me change the page of my notes. This is a page in which the reactions of the period 3 oxides are shown. We need to find the reaction of aluminium, silicon and phosphorus. So here if I zoom it, it says that aluminum oxide does not react or dissolve in water, which is why aluminum oxide layer protects aluminum metal. So we can select this option as wrong because it does not show the vigorous reaction with the water. The second compound is about silicon oxide. So moving to the silicon oxide, silicon oxide is also insoluble in water. It is insoluble in water, which means it does not react with the water. So that slight reaction is also impossible. It is not correct. It is incorrect. Now about the P4O10. P4O10 shows a vigorous reaction with water. So yes, that's right. So this option becomes right. So what we see here, we can see that all the options of the option C are correct, and that's why option C is the right answer. Now the next question, number 18. Which statement is correct? The atomic radius of silicon is larger than that of aluminium. I just need to draw a small periodic table here. We have boron in group number 3, carbon group number 4, and below boron is aluminium, and below carbon is silicon in period number 3. This is the third period, this is the second period. So atomic radius of silicon is larger, so this is incorrect because the atomic structure of aluminium is larger than the silicon, so it is incorrect. The boiling point of chlorine is higher than that of silicon. So boiling point of chlorine, again, if we check the same page, you know that chlorine is a gas. So considering that chlorine is a gas and silicon is a solid, so chlorine cannot have a higher boiling point than silicon. Here is the page again. Although it does not contain the boiling point heading, but it contains the melting point value. So over here chlorine is -101 and silicon is 1410. So you can see the difference, which means it is incorrect. The first ionization of sulfur is greater than that of phosphorus. Now sulfur belongs to group number 6 and phosphorus belongs to group number 5. We should remember and recall the exceptions in the ionization energy values of group number 5 and 6, which indicates that the value ionization energy of the group 6 is smaller than the ionization energy of group number 5. So whereas here it says ionization 6 is greater, which means it is incorrect. CE has smaller ionization energy, and there is a reason behind it. You should remember that. Now the D option, the electrical conductivity of magnesium is greater than that of sodium. So remember that electrical conductivity is associated with the presence of the valence electron as delocalized electrons. So when valence electrons are delocalized, the electrical conductivity is higher. When they are more, the electrical conductivity is higher. Magnesium group number 2, so it has magnesium plus 2, sodium has plus 1 charge. So magnesium has greater number of delocalized electron in the metallic structure. So yes, option D becomes the right one. Now the next question, number 19, is already done in another video of another person. Check out the video link in the description section. Now question number 20. Question number 20 says, what is the total value of the gas produced measured at room temperature when this mole of anhydrous magnesium nitrate is completely decomposed by heating? Okay, now for this purpose we need to first of all recall the equation of the decomposition of nitrate, especially magnesium nitrate, and all the group 2 nitrates have the same chemical equation. Magnesium nitrate is converted into magnesium oxide plus 2NO2 gas, and magnesium oxide is solid plus half of O2 gas. Now here we need to use a stoichiometry. Here we are provided with the moles, stoichiometry moles. Remember, we need to find the value of the gas, volume of the gas. From here we have only these two compounds in the form of the gas, whereas magnesium oxide, as you know, is a solid, so we will not include the value of magnesium oxide. Stoichiometry is saying we have 1 mole of the magnesium nitrate and we have 2 moles of nitrogen dioxide plus half mole of the O2, so it gives you 2.5 mole, and the values which are given in the question is 0.01 mole for magnesium nitrate, so I will write 0.01 mole over here. So then this will become X. We need to find that value, so I will write the ratio method. Magnesium nitrate ratio NO2 plus O2 as combined. We have 1 for here, 2.5 for here. This will become 0.01 for magnesium nitrate, and this will become X. The X value will become 0.01 times 2.5, and the answer is 0.025 mole. Now this is the value of the gases combined. Now we know the relation that 1 mole has how much value if gas is considered at the room condition, as mentioned in the previous question. One of the previous question also said that 1 mole of any gas, 1 mole of any gas contains 24,000 cm cube at room temperature. So we got this value. Since the value is 0.025 mole, so we'll, for this mole, we'll multiply 24,000 into 0.025, and the answer becomes 600. The value is 600 cm cube. So right after, the answer becomes C option. Then about the next question, question number 21. A sodium halide NaX is reactive with constant sulfuric acid. The lowest oxygen state of sulfur in the product is +4. Halogen Y2 is less volatile than halogen X2. What are the identities of the sodium halide NaX and halogen Y2? Now we need to consider some of the points here. We have these options A, B, C, D. Sodium halide is given and halogen Y2 is given. As we know, the compounds of the halogens, especially the NaX compounds, react with the sulfuric acid, and we get different products, or you can say different oxygen states of the sulfur. If we recall that since we are given these two options, bromine and iodide, so it means we need to remember the reactions of these two ionic compound with the sulfuric acid. So NaBr, when it reacts with the sulfuric acid, it is again given in my notes. We get the SO4, but when NaI reacts with the sulfuric acid, we get SO2, we get S, we get H2S as products of the sulfur. I'm not writing all the products of sodium bromine, I'm just focusing on the oxidation state of the sulfur. Now let's check the oxidation state. The oxidation state of sulfur is +4 in SO2. My mistake, is not SO4, it is SO2. So it is 4 in the same SO4 of the compound, and it is 0 in this case, and it is -2. Now the question states that lowest value of sulfur should be +4. So +4 is present in both, but that is the only lowest value for NaBr. So that's the only product, which means it cannot be iodine cannot be there. So we'll say that these two options becomes incorrect. Sodium iodide, these are incorrect. Now one more thing, what we have done here, we have basically identified the element X here. The element X is now determined. It is what? It is bromine. X is bromine. Now it says that halogen Y2 is less volatile than halogen X2, which means this X is converted into X2. We should now recall the volatility rule. Volatility or volatile property is associated with the intermolecular forces. The greater the intermolecular forces, the greater the smaller the is inversely proportional to intermolecular forces. I can write it as 1/, intermolecular forces. Those compound which has greater intermolecular forces has lesser volatile property. And when we write in terms of the order, then we can see volatility order. I2 has least, and then after that comes bromine, then comes Cl2, and then F2. So fluorine has the highest volatility and iodine has the least volatility. Now we have already identified X. X is, as we know, is a bromine. Now they say Y2 has less volatile. So if we check, iodine can be Y2 because it has less volatility than bromine. So Y2 becomes the iodine, and it is not a chlorine, it is not a bromine, and it is not an acetylene. The only option left is B. That's the right answer. Now question number 22. Question number 22. Compound Q dissolves in water. Q does not react with dilute sulfuric acid. Q aqueous form precipitate when aqueous silver nitrate is added. The precipitate is partially soluble in aqueous ammonia. What could be compound Q? Barium bromide, iodide, magnesium bromide, and iodide. Now we have to check this very critically. The compound Q is the one which contains either barium and magnesium. Now when it says that it dissolves in water, so we need to check the trend of the group 2 elements: beryllium, magnesium, calcium, strontium, and barium. Down the group, their power to dissolve in water increases, the solubility increases. So all of them are basically almost soluble. They are all soluble. So we can say that both magnesium is soluble and the barium is also soluble. Both are soluble, but that does not differentiate them. We need to check the reaction with the sulfuric acid. Now that's the main point. We know that when barium in the compound form and aqueous form reacts with the sulfuric acid, it forms the barium sulfate, which has a white precipitate. And because of formation of white precipitate, it does not further react with the sulfuric acid. But the thing is that barium sulfate was soluble in the water and it was converted into the precipitate. It was initially soluble and then it was converted into precipitate, and when it becomes precipitate, it becomes insoluble. When it becomes insoluble, it can react with the sulfuric acid, but that is now stopped. It is now stopped. The reaction has been stopped. On the other hand, magnesium is water soluble, and when it reacts with the sulfuric acid, it forms magnesium sulfate, and this magnesium sulfate is very soluble in water. It is mentioned in my notes. You can see in my notes it is said here magnesium sulfate is reasonably soluble in water. It is very much soluble in water. Now what happens here? When it is very much soluble in water, it means it cannot react with the sulfuric acid any further because it is already soluble in water. How it will react? Any compound can be reacted only if it is in the precipitate form, but we do not know up to how much amount of precipitation formation will restrict the reaction with the sulfuric acid in terms of barium. But we do know that magnesium sulfate, when formed by reaction with the sulfuric acid for magnesium, will give you magnesium sulfate, which is very much soluble, fairly soluble. So this cannot be reacted, which means the options of barium becomes incorrect and we are left with the options of magnesium. Now we have already found the cation or the metal part of these compounds. Now we have to check the negative part or the halide part. The second statement says that Q forms the precipitate when aqueous silver nitrate is added. This precipitate is partially soluble in aqueous ammonia. Now if you remember the reaction of ammonia with the silver chloride, so here we have silver bromide and silver iodide. For when ammonia is present in the either concentrated or sulfuric, in the concentrated or diluted form, it can dissolve the chloride precipitates. There is no formation, by the way, there is no formation precipitate of chloride, but yeah, there is a formation silver chloride precipitate, but they are completely dissolved even by a dilute form of ammonia. But for bromine, it is partially dissolved by concentrated ammonia when the ammonia is in the concentrated form or excess amount. And for AgI, the precipitates do not dissolve at all, even if the ammonia is taken in the small amount or the excess amount. So the question is about partially solubility, which means the it is asking about the bromide. So the incorrect becomes the iodide. Iodide is incorrect, so the only left option is bromide. So the right answer becomes C. C is the right one. The next question, number 23. Nitrogen dioxide is a gas that contributes to air pollution. It is produced in internal combustion engine. What statement is correct? Okay, nitrogen dioxide, first of all we'll leave this part 1. Now come to part B. Nitrogen dioxide reacts to form nitrogen monoxide in the catalytic converter car exhaust system. No, that's incorrect. NO2 does not convert into monoxide. Instead, NO2 converts into the nitrogen N2. Then option C, pan forms when pan is a kind of smoke. It's a kind of pollutant here. Peroxyacetyl nitrate, it's a complete form. Peroxyacetyl nitrate. It is formed by complete combustion of the fuel? No. For complete combustion, you will not get the pan. You will only get pan when there is an incomplete combustion, because the volatile organic compound VOCs, volatile organic compounds, react with other compounds to make the peroxyacetyl nitrate. When C react with the NO, nitrogen dioxide, then you get the pan. PAN. So it only happens in incomplete, so this becomes incorrect. And D option, under high pressure in internal combustion, then nitrogen dioxide forms from impurities in the fuel? No, it is not being formed by the impurities. Instead, it forms by the presence of the nitrogen gas and oxygen gas. These two are not the impurities, these are the gases, so it also becomes incorrect. Now option A, nitrogen dioxide acts as a catalyst in the atmospheric oxidation sulfur dioxide to sulfur trioxide. So yes, from conversion of SO2 to SO3, nitrogen dioxide works as a catalyst. You can check this in literature as well. So yes, the right answer is A. Then next question, number 24, what is the bond angle in the ammonium ion? Ammonium ion is NH4 positive, and you should remember its structure formula. N has 4 hydrogen atoms bonded with the nitrogen, but this is a 2-dimensional form. I have to write in the 3-dimensional form. Nitrogen has 4 hydrogens in this 3-dimensional form. In this case, the angle between the nitrogen to hydrogen becomes 109.5. It is a tetrahedral structure, so the correct answer becomes C. Now comes the 25th question, which is basically the first question of the organic chemistry. Now here, the question is tricky. The structural isomerism, stereoisomerism should be taken into account when answering this question. The structure of 3-methyl cyclobutene is shown. This is the structure of cyclobutene. A mixture containing all stereoisomerism, this should be treated with HBr, and you get a mixture of isomeric bromomethyl cyclobutene. How many stereoisomer does 3-methyl cyclobutene have, and how many isomeric bromomethyl cyclobutenes are? Now the words are very much lengthier, so it becomes confused what they are asking and what we have to find. Okay, I will make it easier for you. Number 1, there are 2 tables. The stereoisomers of 3-methyl cyclobutene, this is the 3-methyl cyclobutene. We have to find the stereoisomers of this compound. This belongs to this one. We have to find the stereoisomers, and stereoisomers, as you know, includes further 2 types. It can be geometrical and it can be optical. So we have to find these cistrons and optical. And then it asks how many isomeric compounds are present when this compound reacts with the HBr. So we have to find the isomers of this compound when HBr is reacted. So there are 2 parts of this question to be answered. I will explain and separately. First, let's go to the first part, which means the first column of the table. They are asking how many stereoisomers of this compound are there. Let's see. Is there any geometrical isomers? means is there any cis trans. So remember, for cis trans, it can only show cis trans when they are two different groups on one carbon, but it should be similar to groups on the other carbon. Let's suppose if it is A, it should be A. If it is B, it should be B. So only in this way it can show cis trans isomer. This is the cis form, and trans is the opposite when A and B of one carbon are replaced or changed. But here you can see that this carbon has hydrogen here, this has a hydrogen here. All right. The thing is that when it is in the form of the cyclic compound, there are no cis trans isomers because they are now restricted. There is a restriction in this movement. So because of that, it does not show the cis trans isomerism in cyclic form. So no cis trans isomers are there. Now we check what about the optical isomers. Are there any optical isomers here? So for optical isomer, we should remember that one carbon should have 4 different groups attached with it: A, B, D, and X. There should be 4 different groups attached with the central carbon. So when we look at here, this carbon has methyl group here. It has one group of this type and another group of this type and one hydrogen here. So considering that, we can see that this steric carbon has 4 different groups attached, and one optical isomer gives one chiral carbon. I will say it is a chiral. One chiral carbon has 2 optical isomers. These are 2 optical isomers of these are dextrorotatory and levorotatory. So one steric carbon is there. Is there any other chiral carbon here? No, there is not, because this cannot be a steric, or this cannot be chiral carbon. Why? Because it has hydrogen here and hydrogen here. So these are 2 same atoms. In case of the doubly bonded carbon atoms, there is one hydrogen here, one hydrogen here, and it has only 3 atoms bonded with it. There is a methyl here and there is a double bonded carbon. So it does not have 4 different groups. It has only 3 different groups. So considering that it does not have any other chiral carbon except for this one, so we have now 2 optical isomers. So from first column we can select option 2 as the right one. Now from the second column we have to find the isomer of the bromomethyl cyclobutenes, which means the isomers obtained when this compound reacts with the HBr. When HBr reacts with this compound, so we have to construct this equation, or simply you have to find the structure. Okay, I'm going to make a little structure here. I have the this is the structure of this compound. It has double bonded carbon, and we know when double bonded carbon reacts with HBr, you get hydrogen on one atom and you get Br on the other carbon atom, which is according to the Markovnikov's rule, or the stability of the carbocation, according to the stability of carbocation. So when this reacts with the HBr, you will get we have one methyl group here as well, CH3. You will get this structure with CH3 here. This is a CH3 here. But what about the above 2 parts? For this case, we need to check that the HBr can be attacking on this double bond in two ways. According to stability or Markovnikov rule, this bromine can either come on this point or it can come on this point, and vice versa for the hydrogen part of HBr. So it means we will get two different products. I can write it can attach over here, bromine will attach over here, and hydrogen will attach over here. And in other case, when there is another reaction with the same HBr, will have another structure. Now in this structure, the bromine will now be bonded on this point and hydrogen on this point. Now we have these different structures. The initial compound was this one. Okay, now consider here, where are the hydrogens located on these structures? There is a hydrogen present here, there is a hydrogen here, you have hydrogens here, two hydrogens on this carbon, and one hydrogen is present here. Same goes in this structure, you have one hydrogen here, one hydrogen here, two hydrogens on this carbon, and one hydrogen here. Now locate the chiral carbons here, because we need to see where the chiral carbons are present. Accordingly, this point is the one where the chiral carbon is present, because there are different groups attached with it. There is a hydrogen, methyl, and this side is different than this side. So there is one chiral carbon present over here. Where is another chiral carbon? Another chiral carbon is present over here, because the hydrogen is attached here, and there is methyl group on this side, and this side is different. So there are two chiral carbons present here, so you will get 4 isomers from this point. We have 4 isomers here. Now in this case, we have this chiral carbon present just like in this structure, it is same. But what about the rest of the 3 points? If we look at here, there is no chiral carbon here, there is no chiral carbon here, because 2 hydrogen atoms are bonded. The same way why I said here that there is no chiral carbon here, no chiral carbon here, because there are 2 hydrogen atoms bonded here, so no chiral carbon. What about this one? Is there any chiral carbon point over here? So the answer is no, there is no chiral. Although it looks like it has chiral carbon, but it does not. Why is it so? Because if you consider the groups bonded on this side has CH2 and this CH3 carbon, and if you move from here, it again has the same group CH2 and this CH3 compound. So considering that these two sides, so let's suppose A and B side, these are two groups attached with a carbon, but they are totally same. That's why there is no chiral carbon on this point, so it has only one carbon. So there are 2 isomers from here, so 2 isomers from here, 4 isomers from this structure. So combining these two will give you 6 in total, and that's why it becomes 6, and the right answer becomes option B. And I hope most of the students have understood this part. Now the next question, 26. The diagram shows the structure of X. Which row is correct? Number of sigma bonds and the type of hybridization of the X atoms in carbon, of the carbon atoms in the X. Now let's check the first group first. First column, number of these sigma bonds. I need to find where the sigma bonds are present. It is there in carbon hydrogen bond, on all the carbon hydrogen bonds. There is one sigma bond in the carbon-carbon double bond, and 1 sigma bond between carbon-carbon, and 1 sigma bond between carbon and nitrogen, because the rest of the two are the pi bonds. There are 2 pi bonds in carbon-nitrogen bond and 1 pi bond in this. So in total we have 1 2 3 4 5 6. There are 6 sigma bonds. Then the type of hybridization. So hybridization can be checked in all the carbon atoms. When we have double bond present between carbon-carbon, then the hybridization is always sp2. The hybridization is sp2 when there is a carbon-carbon double bond, and when there is a carbon triple bond with N, then we have the sp hybridization. There is an sp hybridization in carbon-nitrogen double bond. So the right option is sp and sp2. So the right option becomes C. Now the next question is question number 27. This question is already solved by another person, so skip this question. Question number 28. This question number 28 is already repeated from the past paper, but there is no video found on YouTube channel on this question, so I'm going to solve it by myself. The question says, which reaction occurs when ethane and chlorine are mixed in diffuse sunlight? So if you remember from hydrocarbons chapter, the reaction between alkane and sunlight in the presence of chlorine gives you free radical substitution reaction. So free radical becomes the right one, and as a result of this reaction, only the hydrogen halide reaction product is formed. So the right answer becomes hydrogen chloride here. So that's the right answer. Option B is the right answer. Now the question number 29 is also repeated and is also solved by someone else, so skip this question. So I'm skipping. Question number 30. So question number 30 says Q is either primary or tertiary halogenalkane. Q undergoes hydrolysis with aqueous sodium hydroxide. The first step in the mechanism of this reaction involves 2 species reacting together. Which row is correct? Okay, you have to learn the SN1 and SN2 here. Q is a primary or a tertiary, so we need to check how can it be a primary or tertiary. It reacts with the aqueous sodium hydroxide. So it reacts with the sodium hydroxide. The first step in the mechanism involves 2 species reacting together. Now we have 2 points here, the first step and 2 species reacting together. If you remember that, we can say about the SN1 based upon 2 steps. There are 2 steps in SN1, whereas in case of SN2 there is only 1 step. There is a 1 step here, but here it says 2 species reacting together. So we remember that in 1 step of the SN2 reaction there are 2 species reacting together. There are 2 species reacting in the SN2 case. And which compound give you the SN2 mechanism? Those are the primary compounds give you the SN1 mechanism. Primary compounds, although it says first step, but here it means not a separate step. Instead it is the intermediate, before the intermediate or single step which has a slow step. One of them is a slow step. So this is the only first step and it is also the slow step. So the right option becomes the primary. And what about the behavior of the hydroxide ion? Hydroxide ion is OH negative in the NaOH, and it is not an electrophile. Instead it is a nucleophile, and that's how the option B becomes the right one. The next question number 31. 2-bromopropane is converted into 1,2-dibromopropane in a pathway involving two reactions. Here's the pathway, and we need to find which reagents and conditions are required. Okay, I'm going to write a small structures of the given compound names here. C, 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 and we need to have bromine on the second carbon. Now what happens, how do we get this last compound, which is 1,2-dipropane, sorry. We have bromine over here, we have bromine over here. So what do you see here, that one bromine has been removed and it has been, or you can say an additional bromine has been taken place on either of the carbon atoms on sides. Let's see how it can be happening. If we consider the ethanolic versus aqueous NaOH reactions, then we remember that aqueous can only give you hydrolysis, which means if this happens on this given compound, then it will give you an alcohol, which means C, C, and OH over here, and C, which is not the right. So it becomes incorrect. Aqueous NaOH cannot be the reagent and over here. And then what for the ethanolic? Ethanolic gives you the elimination reaction. So when it happens, it will remove the bromine present on the second carbon. So you will get which compound? C, double bonded C, and single bond C. There is no bromine here. You have removed the minus HBr has been removed using that compound, ethanolic NaOH. So I can write it here, ethanolic, ethanol plus NaOH is the right option here. After that, which compound will give you this? Now from here you are getting this final product. How can you get this? Can you react with HBr? No. If you get with HBr, then you will get only one product. Sorry, we will get one product, but it will contain only one bromine, either here or on the second carbon. So there will be no two carbon atoms. But if you react with the Br2 in the liquid form, then you will get the two bromine atoms on the carbon atoms. So yes, the right option becomes the Br2, and that's how the right option becomes the D. D is the right option. Question number 32. This question is already attempted and it is a repeated question, so you can get the video from the description. Question number 33. Which reagents could be used to form 2-bromobutane from butanol? Again, I need to write the structures. You need to do this conversion. You have to find CC Br, which is from, I can write over here as well, C, this is a 2-bromobutane, and butanol is COH CCC. Okay, you have to convert this butanol into 2-bromobutane, which means you have removed this OH and you have inserted bromine on the second carbon. So option A is incorrect, because this is used for the free radical reaction, which is incorrect. Option B says you are using sulfuric acid potassium bromide under reflux. Sulfuric acid can be used to remove the alcohol, not the bromine. Sorry, you can use sulfuric acid to remove the alcoholic part from here, so it can be used, but with potassium bromide it will not give you the right product. And C, concentrated sulfuric acid followed by bromine. So if you use this option C, it will remove the OH plus H water, but after reacting with the bromine, it will give you two products. It will give you two bromine atoms. You will have bromine over here and bromine over here, which is incorrect. But for option D, it is used to remove the OH, or you can say HBr. Yes, it means OH and H both, which means H2O has been removed, followed by the addition of hydrogen bromide. So yes, when it happens, which means carbon double bond was made in the first step, that was now added by the HBr, and you got the carbon Br on the second carbon. That's how you got the right answer. So option D is the right one. Option D is the right one. Now the question, next question is about the ketone. Question number 34. X is a non-cyclic ketone with a single carbonyl group and no other functional groups. Ketone X has the following properties. Okay, so ketone X is that ketone which, when reacted with the NHBH4, gives you MR value of 2.3256% greater than that of the original ketone X. So the product which is obtained when ketone X reacted with the NaBH4 is, as you know, the reducing agent, will give you a product Y, let's suppose. Then the value of Y is about this percent. The MR value of this Y product is greater than by this value from the original ketone X. And the second point is ketone X gives a yellow precipitate with alkaline I2. So using these 2 points, we have to identify the actual ketone which is now present here. Okay, it says that it is also a non-cyclic. That's another point, and it has only one carbonyl group. It is also another point, and there is no other functional group. That's another point. So we can consider all these points to draw the structure of the ketone. Okay, I will try to use this structure or draw this structure, the one which has 4 carbon atoms, because I also have to consider that the ketone will react with the alkaline I2, give you yellow precipitate. This is the iodoform test, which means it must have this part, CH3COO, this part. It should have this part linked with it. So I cannot include any carbonyl part other than this, so I will have to use this part or this part. Both means the same. So there are 4 carbon atoms, and it is non-cyclic. It has single carbonyl. There is no other functional group, and this can also give you the iodoform test. So all the points are applicable on this structure. Now we have to prove it by the first point. The first point says that it reacts with the NaBH4. Then you know that NaBH4 is a reducing agent, and it will convert it into an alcohol, CCOH and C. I'm not writing all the hydrogens to make it easier. Now it says that the change in the MR is about 2.3256%. First, let's calculate the MR value of the original ketone. This original ketone has 4 carbon atoms, 1 oxygen atoms, and how many hydrogen atoms are there? 3 plus 3 6, 6 plus 2 8. They are 8 hydrogens. So calculate the value of this original compound.